So yeah, today we'll see these questions. Okay. Okay. Can you first question is mention two basic applications of flip-flops. What is the difference between latch and a flip-flop? Can anyone answer for the question?
Ma'am,
First of all,
the
what is the
flip,
difference between? Yeah.
Latch is level triggered, ma'am.
latch is level triggered while flip flops are edge triggered.
Edge triggered.
Okay. Okay.
And flip-flop are
Flip
used
flops
in
are
registers.
flip
Latch
flops
doesn't
are used in
require a clock,
Latches
whereas
are made with
flip-flop
the help of
requires
gates,
a clock.
Wait,
and
wait,
flip
wait,
flop
wait,
with
wait,
latches.
wait. Yeah, wait. Okay, Kirti, tell.
Yeah, latch doesn't require a clock pulse, while flip-flop requires a clock pulse.
Okay. Any other answers? Others other than Abjit and Kirti?
Ma'am, latch is level triggered, flip flop is edge triggered, and
Completed.
the applications of flip flops are registers and counters, shift registers and counters.
Okay. What is the application of
Latches,
register?
It is used to shift the data,
Only for shifting?
shifting and storing.
Okay. What is the application of counter?
It is used to count the number of states, or it is used to up count, down count, etc.
Okay. Okay. Any other answers?
Also,
Ma'am,
ma'am,
latch,
counters are used to clock the number of count the number of clock pulses as well.
Okay. 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 As we told that, okay, flip-flops applications are nothing but it will store the data for the data storage purpose and data transfer purpose, counting purpose, frequency divisions. Okay, mainly in clocks, we can use either watches or alarm. Okay, mainly counters are used in the flip-flop. Like flip-flops are used in the counters, right? So, okay. So, how many bits the flip-flop can be stored?
Ma'am, single bit.
Okay, what
single
can
bits
we
only.
do to store multiple bits? What about others? Can anyone answer other than these students? Okay,
Multiple
to
flip
store
flops.
multiple flip-flop. Multiple flip-flop in the sense it is nothing but
Registers.
registers. Okay, so those are the applications of flip-flops. And difference between flip-flop and latch is a level sensitive. Because of level sensitive, we are facing so many disadvantages. Okay, occurring glitches at the output side. Glitches in the sense nothing but the output is not stage not in a constant way. Glitches in the sense moving like this. Okay, 0 1 0 1, actually it should be constant for certain time, right? But due to latch, due to level triggering, the output doesn't have the controllability on the inputs, right? So because of that thing, we are facing the glitches at the output side of the latches. That's why we are moving to the flip flop where it is a edge triggering. Edge triggering means only at the particular edge of the clock, whether it is a positive edge of the clock or a negative edge of the clock, only at the particular edge of the clock only the output will be changed with respect to that input, right? So that's why latches are not mostly preferred due to this advantage. And for latches we are facing the race around conditions and all, right? The best solution for race condition is we can we can increase the propagation delay of the flip flop. Okay, that is more not more efficient manner. If you increase the propagation delay also of up to some time only, we can make the constant value. Okay, so up to some time only we can make, otherwise again it will go to the same glitches will be occurred. So making increasing the propagation delay is not the main solution. So we are moving to the master slave JK flip flop or master slave D flip flop, that like that master slave connection. Master slave in the sense we are taking two number of latches in the sense here we are taking the clock in a inverter manner. So if one latch is on, another latch is automatically off, so that we have the good controllability on the output without getting the race around conditions. Otherwise, the best thing is a edge triggering. Okay, we can use the edge triggering so that we can avoid the race around conditions. That is main disadvantage of latch. Okay, and latch will take the less number of gates. Latch will have the less number of gates so that it consume the less power. But flip-flop is more efficient, right? Functionality wise, working wise, flip-flops are good. That's why we are moving to the flip-flops. Whereas latches are faster than the flip-flop because it doesn't have the clock and all less number of inputs will be there. So latch will be the faster than the flip-flop, and area wise also it is efficient, but moreover we should get the proper output, right? So flip-flops are mostly considered. Okay, so that is the main difference between the latch and the flip. Okay, so next question is a 4-bit shift register which shift the data Q0, Q1, Q2, Q3 is shown in the above figure. The initial value for Q0, Q1, Q2, Q3 is 1000. And write the 4-bit values for Q0, Q1, Q2, Q3 after each clock pulse until the pattern receives 1000. Okay, so to what values should the shift register will be initialized so that the pattern 1000 occurs after 2 clock cycles? After 2 clock pulses, what is the shift register value? Okay, so what is the shift register given here? So Q1 is 1000. They're telling us 1000. So you need to perform the XOR operation also here. So we'll see, we'll take 1000. Now can you tell me what is the value for the next clock cycle?
1100.
1100. Okay. So how
Again,
it is
1110.
wait, 1100, how it is here we are giving as a 0, here also giving as a 0, and here it is a 1. So for the next clock cycle, here we'll get the output, right? So 00 means output. What is the output? 00 is 1. Here 11 is nothing but output is a sorry, here XOR
0.
000, yeah, 00 as a 0, here output as a 1. So this output, this bit will be, that means this bit will be shifted to 1, and whatever the bit here getting shifted to 1 here, and 0 here, and 0 here. Okay, did you understood everyone? 1100. And next clock cycle, it is 110.
111.
Okay, here also 00, here also 1. So 00 means here 1 will get, and 11 means here 0 will get, right?
0, 1.
Sorry, wait. Yeah. So again here we are getting a 1, and here also 1, 1, 0. Okay, so like that you need to perform here. And next, can you tell me quickly all? 1110.
Yes, ma'am.
1110 means
0,
011. So here
Yes,
we'll
ma'am.
get 0.
00,
All
11.
ones will be shifted like this. Okay, next
Yes, ma'am.
0011.
0011. Yes. Then
Yeah.
0001.
0001.
And ma'am, then
1000.
1000. Yes, ma'am. So after 6 clock pulse, we are getting our required.
So after 6 clock cycles, so we are getting same value here, 1000. So they have answered, they have asked the question like at second clock cycle. What is the second clock cycle? So at the first clock cycle, it is shifting like this. And this is the 0 clock cycle, first clock cycle, and the second clock cycle. So second clock cycle, the value is 0011. 0111. Okay, so that is how the shift register will work. Okay, So did you understood everyone clearly? Did you understood everyone clearly?
Yes, ma'am.
This is also one of the important question for the interview. Okay. Just you need to take the values here, whatever the given value is there, and you can apply here, and you can check what is the output and will be shifted.
In second part they are asking after how many cycles will 1000 will occur after 2 clock pulses. So we need to initiate according to that. So answer should be 0011.
0011. Okay. So to what value
Because in this
should
case, yes, ma'am.
okay, after 2 clock pulses. Okay, 2 clock cycle means it will be the value. So after 2 clock cycle means 0011. Okay. Here is an interesting question. Like there is a room which has two doors, one to enter, another to leave. There is a sensor in the corridor, at the entrance, also at the exit, and there is a bulb in the room which should turn off when there is no one inside in the room. Okay, so imagine a black box which with the inputs as the outputs of sensors. So what should be that black box be? Suppose if you imagine a black box, okay, as a room, there will be two doors, one to enter and one to leave. Okay, and there is a sensor at the corridor, at the entrance, and also at the exit. And there will be a bulb in the room which should turn off when there is no one in the room. That room is nothing but black box. So black box with the input and output sensors. Based on sensors only, the light will be off and light will be on, right? So what is that black box? Light will be
Ma'am,
on, light will be off. Based on
ma'am,
the
can we use an multiplexer, ma'am? So let's suppose if we have if we take the first input as the entrance and the second input as an exit, ma'am, and we take it as a
Hmm.
and we take
Okay.
this and we take the select if we take it as the select lines and
Hmm. By using the select line, you
Ma'am,
can take.
yes, ma'am. Here we can use a counter that counts up and down both. So we can have we can basically design that using a mux and a counter. So whenever so the first mux we will connect at the first door, and the second mux will be connected to the second door. So whenever someone will enter in the room, the counter will increment, and wherever someone exit, the counter will decrement that.
Okay. Okay, so we can also use counter, and we can use the multiplexer, but some modifications need for multiplexer, like it should be on and off, right? So if you use the 2x1 multiplexer based on the selection line, if it is a 0, we can tell as a off. If it is 1, we can tell of as a on. But what is the stationary, like if there are no one in the room? Okay, so how the bulb will be off? Okay, you need to understand that thing. Otherwise, we can use as a up down counter. Okay, like for up down counter, we have the count up enable, count down enable. You know the down up down counters, modulo counters, right? So for 2-bit, for suppose if you take 3 number of flip flops, it will count up to 8 number of clock cycles. Up down in the sense it will count for up 0 to 7, and down means it will count from 7 to 0. Okay, this is for up down counter. If you take the modulo counter, we'll discuss modulo counter later. So here, for up counting and down counting, we should have two enables. Okay, based on the enable, if up equal to 1, it will count up count. If down equal to 1, it will count down count. So we'll have up count up enable and the count down enable. So count up enable we can take as a entrance connected to the sensor entrance. At the entrance we can connect here. So what happens if you connect to entrance here and down enable is connected, that sensor will be connected to the exit. So if there are no one in the room, the counter output must be 0. If counter output must be 0 means it will be off state. The bulb will be off state. Okay. If entrance is 1, like why we are taking it here, entrance up counter means number of people will be coming inside, right? If there are 100 number of people, okay, so the count will be incremented one by one. So one people, 2, 3, 4, 5, 6. So some value of counter we can put at the entrance so that it will increment the count based on the number of people and in the room entering into the room. If anyone go outside at the exit side, if anyone go outside, the count must be decreased, right? So if there we are putting the down counter. Suppose here the count value is 50 means total number of people in the black box is a 50 means total count. At the exit side, if anyone going out, it should be count as a 50, 49, 48 decreasing. It should come like a 0. Okay, so here it is for counting the people, here for exiting the people. Okay, so both are not there. Here entrance, whatever 50 number of people there, those all 50 number of people went out, okay, at the exit, from the exit. So what is the count value? 0. Whenever the count value is equal to 0, we can tell that bulb must be off. Otherwise, bulb must be on. Did you all understood how we can implement?
Yes, ma'am.
Yes.
Okay,
Yes, ma'am.
so based on your number of people, okay, how many number of people should enter? If there are 8 number of people, you can implement the 3-bit counter, which count 8 number of people. If you are taking for 100 number of people, okay, 2 power 6, I think 2 power 5 is for 32 only, right? 2 power 6 or 2 power 7 counter you can use. If there are 2 number of people, based on the 2 number of people, 8-bit counter needed. 3 number, 500 people, like that you can use the counter design. Okay, simply like for digital watch, digital alarm. Okay, so many things you can use for the by using the counter. Okay, everyone clear?
Yeah.
Okay, suppose if
Digital,
you tell.
ma'am, digital alarm, how can we use?
That's what I'm telling. Digital alarm in the sense based upon our design engineer. Okay, some digital watches will have 24 hours clock, 59 seconds, 0 to 60, 0 to 59 and 59 seconds. Like this it will be there. For some alarm there will be 0 to 1 to 12. Okay, only 12, and from again 12, again it will start from 0 to 12, right? So from 12, 59 is to 59. So 2 times we can implement this. So what type of counters are required for this? What type of counters?
Up.
Huh? Tell. What is the need of mod counter? What is the need of mod counter?
Ma'am, to count
If
a
you want
particular
to
number of
count,
bits.
if you want to count only 9 clock cycles, a counter should count only between 0 to 9. 0 to 9 means how many bits it will require? 2 power 4. 2 power 4 in the sense is 16 number of combinations, 0 to 15. So total 4 flip-flops are required. Based on the 4 flip-flops, we can design the counter. Okay, from 0 to 9 up counter. So by at the end of 9, what is the value of 9? I think 1001 for 9. So whenever it is 1 1, we should connect with the gate which is an AND or AND for the clear input. So here we'll have 4 number of flip-flops: flip-flop 1, flip-flop 2, flip-flop 3 and flip-flop 4. Okay, these 4 flip-flops is counting from 0 to 9. 0 1 2 3 4 5 like that. Once it reach 9, it should not go to 10. It should go to again 0 state. It should go to clear state, 0 state. Okay, so it should go to clear state means what we need to do here, output is generating as a 1. Here output is generating 0. Here output generating 0. Here output generating 1. Next state, all the outputs should be go to 0 state. 0 state means whatever the 1 here, 1 here, wherever the ones we have, these two ones will connect to the one AND gate or one NAND gate based upon your clear signal, whether it is a active low or active high. Here 1 1 means output will be 0. 0 in the sense you need to take clear signals, clear variable as a active low, because active low only 0 will be activated, right? So here clear is the active low. Here also clear signal is the active low. Here also clear signal is the active low. Here also clear signal is the active low. So whenever it got the value 0 here and 0 here, 0 here, 0 here. So all 0 means clear signal is activated. So all flip-flops will get output as a 0. It will count only from 0 to 9. Okay. Okay, did you understood everyone? So this is how
Yes.
we can make the modulo counter, whatever the modulo. So 24 in the sense how many bits it required, 2 power 4 or 2 power 5, I think 2 power 5. So total 5 number of flip-flops will be there. You need to make here 24 modulo 24 counter. So whatever the binary value is there for 24, you can connect in the same way. Like that modulo 59. Here also modulo 59. So these type of counter implementation you need to perform for digital watch. Okay,
Yes, ma'am.
clear? Up to here, everyone clear?
Yes, ma'am.
If say anyone don't understand, please you ping me in the WhatsApp. Okay, everyone, it's not everyone won't understand all the things in the session itself, right? So if anyone not understand the things, please ping me in WhatsApp. We can discuss the things. Okay. Next one, draw the CMOS implementation for the circuit which is given here. What is the circuit given here?
Ma'am, A plus B into C plus D. A plus B into C plus D whole bar.
Oh, okay. A plus B into C plus D whole bar. So A plus B into C plus D whole bar. So how can we design this thing?
Ma'am, we
First,
can
consider
take
this. Yeah. If you go to digital logic design, this here you will get to know how to implement NAND, NOR. For NAND, what it is a connection? Can you please join for the session again quickly? All, everyone, please don't leave.